Welcome, guys. I am Cornelius Ijeboa, Computer Science Group A class, and we are working on the computer architecture project work. And then here are my colleagues.
I'm also Ahmed Kamal.
And
Kelvin Labi.
And
Mino Emmanuel.
Okay, so guys, join us on this journey of getting educated on the memory system, the memory units, the memory addressing, and a whole lot of stuff.
I'm Mino Emmanuel, and then I'll be presenting on memory addressing. Memory addressing in computer architecture is a method used to locate and access data stored in a computer memory. It involves assigning unique addresses to each memory location, enabling the computer to read from or write to a specific location. So, memory address is a reference. The definition for memory address, that's what I'm giving right now. Memory address is a reference to a specific memory location used at various levels by software and hardware. Memory addresses are fixed length sequence of digits, conventionally displayed and manipulated as unsigned integers. And then there are two types of memory addresses. That is the physical addresses and then the logical addresses. So I'll be defining the physical addresses. That is, when we say a physical address, it's a digital computer's main memory that consists of many memory locations. And then the logical addresses is a computer program. The logical addresses is used in computer programming. So a computer program uses memory addresses to execute machine codes and to store and retrieve data. And then the units of addresses resolution, we say most modern computers are byte addressable, and then each address identifies a single byte of storage. So that's what I have on memory address.
My name is Kelvin Labi. Today I'll be presenting on memory system. In computer architecture, the memory system is crucial. It's where the CPU fetches instructions and data. This includes ROM and RAM. We know RAM to be random access memory and ROM to be read-only memory. RAM is the computer's short-term memory where data that is currently in use is stored. It is called random access because the memory cell can access data directly, providing quick and retrieval of data. ROM, on the other hand, is more like the computer's long-term memory. It stores essential data that provides computer with all they need, such as instructions for booting up. Once data is stored in ROM, it cannot be modified, deleted, hence name read-only. There are two types of RAM, which is DRAM and SRAM. DRAM, dynamic random access memory, and SRAM, static random access memory. The DRAM stores each bit of data in separate capacitor with an integrated circuit, whilst the SRAM uses its flip-flop circuitry. Thank you.
Guys, my name is Ahmed Kamal, and I'm here to represent on flip-flop as single-bit cell storage. Okay. In the single-bit cell storage, there are 5 points, and now 1. Binary state storage. The binary state storage are the zeros and ones. Flip-flop are fundamental building blocks in digital circuits and are in bit informations. Okay. This can be in zeros and ones and are often referred as the binary values. Point 2. Clock signals. Flip-flop are typically driven by a clock signal. The clock signals controls the flip-flop update controls when it is on output basis and its inputs. This synchronization ensures that data is only stored or charged specific times. Point 3. Types of flip-flops. There are various types of flip-flops, including D-type, JK, SR, T-type, etc. Each type has a unique character or functions, such as toggling behavior, preset, clear input, and feedback loops. Point 4. Sequential logic. Flip-flops are crucial component in sequential logic circuit, where the present state depends not only on the current input but also on the previous state. This enables the creation of memory elements and implementation of tasks like counting, storing data, and generating controlled outputs. Memory and register as point 5. Multiple flip-flops can be combined to create large storage units like registers and memory banks. These units allow for a storage and a manipulation of multiple bits of data, forming the fundamentation of computer memory and data processing. Remember, flip-flops serve as the basis for more complex digital systems, and their reliable behavior is essential for the correct operation of digital electronics. Thanks.
So, once again, I'm Cornelius Ejeyeboah, and I'm going to give the summary on everything that was said in the video. Memory storage refers to the process by which information is encoded, stored, and received in a human form. It is a complex system that allows us to retain, recall, experience, knowledge, and skills. So we store data and information in the memory. We retrieve those information for other purposes, for future purposes. That's the reason why we store information. Okay. So there are three main stages of memory storage: encoding, storage, and retrieval. Encoding involves the conversion of sensory information into a form that can be stored in the brain. This process can occur through various means, such as visual, auditory, or semantical encoding. The more attention and efforts we put in encoding information, the more likely it is to be stored effectively. So this one basically talks about how we store information. So the more effective you store information, the more trivial or useful the information becomes. Once information is decoded, it moves to the storage stage. So once you give information to the computer, once you put information to the computer, the computer receives information, it processes it and then stores it. And that is what is basically the memory. That's what the memory is all about. So memory storage is not a single unified location in the brain, but rather a distributed network of neural connections. Different types of memories are stored in different areas of the brain. So we also spoke about the types of ways of storing information: the binary storage, the flip-flops, the clock signal, the sequential logic in the memory and registers. The memory and registers can be found in the system units. The binary state storage, which basically talk about the flip-flops and then the fundamentals of building blocks in a digital circuit, used to store a single bit of information. The clock signal, typically divided by a clock signal. The clock signal controls when the flip-flops updates the outputs based on its inputs. The flip-flops there are various types of flip-flops: the DK, the D-type, the JK, the SR, and then a whole lot. Each type is unique, has its own unique characteristics. The sequential logics, crucial components in sequential logic circuits, where the circuit presents only the current inputs. Okay guys, so let's move to the types of RAM. That's the SRAM, the DRAM. The DRAM is called the dynamic random access memory. The DRAM got its name because to be able to access information from the DRAM, you need to gradually or consistently refresh the page or the data to be able to get access to it. The SRAM, that's the static random access memory. It's static because information is basically at a constant place. So basically what all this is about is the memory storage. So we've spoken about the memory addressing, the flip-flops, which speaks about how the computer gains the capacity of information stored on it, how the memory is stored, how memory is processed, the types or ways of storing memory, and then the types of RAM. That's the DRAM and the SRAM. So I hope you guys are educated and a whole lot more to come. Thank you.